All right, welcome back, everyone, and a huge welcome to all the software developers and DevOps engineers joining us today for this explainer. Look, if you work in modern engineering, you already know about one of the most frustrating bottlenecks we face, that endless manual human reading loop, especially when it comes to hardware diagnosis and OEM certification cycles. Seriously, it's painful. You're constantly cross-referencing raw kernel logs, massive PDF spec sheets, deep Jira histories, maybe even hunting through random Slack threads just to figure out why a single piece of hardware failed. It's slow, tedious, and honestly, super prone to human error. But what if we could just automate that whole triage process directly inside our pipelines? Well, that's exactly what we're tackling today as we walk through a hands-on guide for integrating this incredible tool right into your workflow. Okay, let's dive right into this Zero to Hero guide. Here's our roadmap for today. First, we'll meet the Alchemy agent. Second, we'll open up the developer's toolbox. Third, we'll cover configuring your workflow. And finally, we'll get under the hood with architecture and execution. All right, kicking things off. Section 1, meet the Alchemy agent. So what exactly is this thing? Meet Alchemy. In purely technical terms, Alchemy is a cross-platform CI/CD AI agent written entirely in Rust and, this is the best part, it's distributed as a single static binary. Now, if you're the one deploying to complex, lockdown environments, I know that phrase, single static binary, is literally music to your ears. We're talking zero bloated dependencies, absolutely no massive container overhead, just a lightning-fast, memory-safe executable that is ready to drop straight into your existing Concourse or GitHub Actions setup. You just point it at a problem, like a failing kernel log alongside a datasheet, and Alchemy produces a beautifully structured, machine-readable triage report. It really doesn't even break a sweat. And this perfectly captures the elegant design of version 0.1.0. You see, Alchemy actually operates in two very distinct modes. First, you've got TUI mode, which gives you this nice, interactive terminal user interface when you just want to poke around and manually interact with the agent locally. But item 1, pipe mode? That's your absolute go-to for pipeline automation. It communicates strictly via standard input and standard output. So you literally just echo your prompt or pipe those raw logs directly into Alchemy and boom, it spits out a machine-readable artifact, giving you the root cause, a confidence score, and a suggested fix. It is tailor-made for headless, automated environments. Moving right along to Section 2, the developer's toolbox. So let's crack open that toolbox. Out of the box, Alchemy supports 6 major large language model providers. We're talking the heavy hitters here. OpenAI, OpenRouter, Anthropic, Gemini, and even GitHub Copilot if you feed it a personal access token. But here's a surprisingly cool detail for those of you who are testing locally or maybe running in a super locked down, air-gapped environment. Llama is supported natively, and it is the only provider on this list that doesn't strictly require an API key by default. You can just point Alchemy straight at your local Llama 3.2 instance and start diagnosing those hardware failures without spending a dime on API calls. Now, what's really fascinating about this next breakdown is the built-in toolset. This is literally how Alchemy reaches out and interacts with your environment. It can list directories, write files, and execute shell commands, all with built-in timeouts to keep things safe. But look closely at read_file and fetch_URL. These two are absolutely critical for grabbing local kernel logs or pulling down remote Jira tickets. Notice that strict 32 kilobyte truncation limit? That is a brilliant little guardrail from the developers. It stops those massive sprawling log files from completely blowing out your LLM's context window. Basically, it forces the agent to read selectively rather than just blindly swallowing a gigabyte of random noise. And you know, execution speed is everything in CI/CD, right? Well, Alchemy handles this really smartly. Within a single LLM turn, your read-only tools like readfile, lister, and fetch_URL, they all run concurrently. So the agent can grab a PDF spec sheet and pull a Slack thread at the exact same time. However, any command that actually mutates state like write file or execute CMD, those are forced to run sequentially. It's a strict rule, but it completely eliminates race conditions when the agent is trying to compile its final triage report or run diagnostic scripts. All right, let's get into the setup. Section 3, configuring your workflow. Alchemy is configured entirely through environment variables, which makes it incredibly easy to just inject right from your CI/CD secrets manager. Obviously, you absolutely need to set your Alchemy_provider and your Alchemy_API key, but I really want to draw your attention to Alchemy max steps. By default, this is set to 30. This is the hard limit on the agent's loop iterations. Think about it. If the agent gets totally confused trying to cross-reference some bizarre, totally undocumented hardware exception, this hard stop kicks in so it doesn't just get stuck in an infinite loop and rack up a massive API bill. It's a crucial, absolutely necessary safety net. Now, if you really want to unlock Alchemy's full potential for OEM certification, you're going to want to use RAG, or Retrieval Augmented Generation. Just flip alchemy_rag_enabled to true in pipe mode, and suddenly the agent can pull from your local context, like your company's own proprietary database of past hardware exceptions. One quick gotcha though, your embedding provider must actually support embeddings. OpenAI, Gemini, and Llama handle this out of the box. If you forget to configure a supported embedding provider, the agent's just going to fail and exit. But once you've got this running, oh man, this is exactly what allows the agent to start from an informed diagnosis, instead of just staring blankly at a wall of raw log text. So, the really crucial point here is how your pipeline actually talks to Alchemy. CI/CD pipelines live and die by exit codes, right? Well, Alchemy keeps things beautifully standard. Code 0 means success. The agent did its job and produced a final triage answer. Code 1 is a runtime failure, like maybe it hit that max step limit we just talked about, or the provider's API went down. And code 2 is a fatal configuration error, like you totally forgot to pass in an API key. Your pipeline scripts need to watch for these exact codes so you can handle any automation hiccups gracefully. Let's peek under the hood. Section 4, Architecture and Execution. I absolutely love this specific detail from the documentation. Listen to this. The agent core is front-end agnostic. Pipe mode and TUI mode are adapters over the same loop in src agent.rs. Seriously, that is such a core design philosophy, and it gives you a crystal clear mental model of how this thing works. If you're a REST developer and you want to write a brand new adapter or tweak how the agent loops, you don't have to waste time untangling UI code from core logic. You just dive straight in to src agent.rs. It's just incredibly clean, solid Rust engineering. And looking at the advanced features that are already up and running in version 0.1.0, the extensibility here is massive. First off, Alchemy acts as an MCP or Model Context Protocol client, operating directly over standard I/O in pipe mode. But it also has this built-in skills system via the agent skills specification, which is just huge. You can write a reusable skill, say, @OEM enablement, that automatically loads up all your certification context and identifies specific failure classes. So every single time Alchemy runs that skill, your data flywheel spins faster and your automation actually gets smarter. It finally lets your engineering team start with a real diagnosis, not a raw log. Plus, depending on how you configure it, it outputs in strict JSON, which is just perfect for downstream parsing in your pipeline. Now, I do want to share a fun little insider detail about the current codebase. You might notice that while the RAG system is fully functional right now, the true optimized database indexing isn't completely switched on yet. The code for a SQLite Vec virtual table is actually in there, but it's not fully wired into the CLI just yet. So for the moment, the RAG store falls back to doing a full scan cosine similarity implemented natively in Rust. And honestly, it works perfectly fine for normal context sizes, but it is a really cool hint at the kind of massive database-level performance optimizations the developers are gearing up for in future releases. All right, we've covered the core tools, the pipeline configurations, and that rock-solid Rust architecture that makes this single binary so incredibly capable. We are finally looking at a real way out of those endless human reading loops through raw hardware logs. So, I'm going to leave you with this. Knowing exactly how that central loop operates and seeing the potential of those built-in skills and RAG systems, how will you extend Alchemy to revolutionize your own automation workflow? Go grab that binary, dig into the Rust code, and start building something awesome. Thanks for joining me for this explainer, and I will catch you in the next one.